All right, so we're going to talk about the law of signs, the ambiguous case. Um, so, um, when you have the law of signs, sometimes you can have more than one triangle. So let's kind of go back to geometry and talk about that a little bit. If you had geometry, you might remember that the side-side angle configuration was not one that proved congruency. And you might remember that because we probably pounded into your head that SSA did not prove congruency, but you might not remember why. So let's take a look at this little example here, and it might make a little bit more sense. So if you take a look at this first triangle, you have angle A is given, side AB is given, and side BC is given. So you have an angle side configuration. So if you look at the first triangle right here, I'll start with this one. So here now I have these two triangles that are exactly the same, angle, side, side. But you don't know this side QR, that could swing this way as well because you don't know what this angle R is. Right now, this angle R is an acute angle, but if I swing that side QR over, it would make R an obtuse angle. And since R is not one of the angles that we know, that you really don't know whether you have that triangle or this triangle. You have no idea which triangle you have. You could have either one. So what that means when we're talking about our law of sines and law of cosines is here's an example where you don't know for sure whether you have, that's probably not a good pen to use. You don't know for sure whether you have this triangle right here, which means your angle that you would be that you would try to find would be an obtuse angle, or you don't know if you have this bigger triangle right here, in which case this would be the angle that you would be trying to find. It would be an acute angle. But let's take a quick look at the relationship between those two angles. So if you remember again from geometry, if you just take a look at this side here, so this red side is the side that could swing in and out either way. So if we had this big triangle here and we found angle B, we could actually calculate it, but I'm just going to make up a number. Let's just say 70 degrees. If we had found out that this angle here was 70 degrees, well, if you take a look at what kind of a triangle this little triangle is right here, this one that's formed by the two 6-inch sides, that would be an isosceles triangle. If you remember from geometry, when those two sides are the same, then these two angles would also have to be the same. So you don't know whether you have this big triangle have an acute angle that's 70 degrees, or you have this kind of shifted triangle over here where you have this angle right here, which is an obtuse angle. But what is the relationship between these two angles here? Well, if this is 70 degrees, this here would be a straight angle. So if this is 70 degrees, this would be 110 degrees. So what I really don't know is I don't know if I have this triangle here, this big triangle here, which would have 33, 70 and angle A, or if I have this triangle here, see if I can draw that one a little nicer. This triangle here, which these two bottoms here would be 33 and 110. You have no idea which triangle you have. So we can work through that a little bit. We can work through that a little bit on this law of signs configuration worksheet. Now, there is a copy of this if you want to print it out so that you can kind of follow along with me. It's probably a good idea. All right, so we're going to go through 3 examples, and I'll show you how you can decide whether you should have 1 triangle, 2 triangles, or perhaps no triangle at all. All right, so they give you some information. They tell you that the measurement of angle A is 103, C is 6, and A is 11. So just draw that in anywhere you want, A, B, C. And so you know A is 103. C, which would be opposite angle C, is 6, and A is 11. So if you take a look, you have an angle side configuration. If you don't want to swear, you could say it's a side angle configuration, whichever you're more comfortable with. All right. So let's write in what we know as far as the angles go. Well, I know angle A is 103 degrees because it has been given. So I know there's no ambiguity with that. It's going to be 103 degrees. So we're going to go ahead and continue doing our law of sines just like we would normally. So I can say the sine of 103 over the opposite side, which is 11, is going to equal the sine of angle C over the opposite side, 6. I can cross multiply, and I would have 11 times the sine of C equals 6 times the sine of 103. And I can divide both sides through by 11. And I know that I have the sine of C equals 6 sine of that. So let me pull up the calculator here. And so I know that I'm going to have 6 times the sine of 103 divided by 11. So I know the sine of C equals 0.531, blah, blah, blah. But I don't really want to know what the sine of C is. I want to know what C is. So I'm going to go second sine of the answer because I want an angle measure, and that'll give me 32 degrees. So now I know that angle C could be 32 degrees. So if this was my acute triangle, then I would have this configuration. Well, I know that a triangle has to equal 180 degrees. So if I go back and just take 180 minus 103 minus 32, I'll get that angle B would be 45 degrees. And that works out perfectly fine because it adds up to 180 degrees. But this angle C could also be the obtuse angle. So angle C could be, the measurement of angle C could possibly be 180 minus 32. Because if you remember, I don't know whether I have, if I'm talking about this angle here or this angle over here. I don't know which angle I'm talking about. If I'm talking about this obtuse angle, then I have to have 180 minus 32. So if it is the obtuse angle, then I know it's going to have to be 148 degrees. So when you're finding this, it's always going to be the measurement that you find using your law of sines, and the other one is always going to be 180 degrees minus the first one you found. Well, now we can clearly see that there's no way I can get this to add up to 180 degrees. I'm already over 180 degrees. So therefore, my answer is that the measurement of angle C can only be 32 degrees because I only have one triangle possible. I don't have any other triangles possible. All right, let's work through the next one. All right, again, this time I'm going to label a little differently just to show you it doesn't matter. I'll go A, B, C that way. The measurement of A is 16, C is 34, and A is also 16. Again, I have the angle side configuration, so I know I'm going to have to be careful. I know I'm going to have to consider not only the answer I get, but I'm going to have to consider 180 minus the answer I get. So let's go ahead and just figure this out. I'm going to find angle C because that's the side I have across from it. So I'm going to say the sine of 16 over 16 equals the sine of C over 34. Sorry, that's my laundry. I'm going to cross multiply, and I'm going to say 34 times the sine of 16 equals 16 times the sine of C. And if I divide both sides by 16, I can go to my calculator, and I can say the 34 times the sine of 16 divided by 16 I'm going to get this number, but again, I don't want to know what the sine of C is. I want to know what the angle is, so I'm going to go second sine the answer, and we'll say 36 degrees because we usually round to the nearest whole number. So I know here that the measurement of angle C is possibly 36 degrees. So again, let's fill out our chart. They gave me angle A is 16 degrees, so I know that has to be true no matter what the triangle is. And I just calculated that measurement of angle C has to be 36 degrees. I know that in the second triangle, angle C is going to be 180 minus 36 or 144 degrees. I don't know which angle C I have. It could be my acute, it could be my obtuse. Let's go figure out what measurement of angle B is based on that information. So I'm going to go 180 minus 36 minus 16. I know that this is 128 degrees, and that works out because it adds up to 180 degrees. If I take 180 minus 144 minus 16, this here will be 20 degrees, which also adds up. So now I could clearly have either triangle works. So my answer in this case would be the measurement of angle C equals 36 degrees, or the measurement of angle C equals 144 degrees. I don't know which it is, so I have to list both as a possibility. All right, let's take a look at the last example. All right, I'll label this one again just a little bit differently. Here, I'll start A, B, C. It tells me the measurement of angle C is 81. Whoops, sorry. Angle C is 81. Side B is 35. And side C is 21. Again, I have angle side configuration, so I know I'm going to have to consider both the acute angle that I get and the obtuse angle that I get. All right. Well, I know this side and this angle and this side. I know this side, so I'm going to solve for angle B because that's the one that I don't know. So I'm going to say the sine of 81 all over 21 equals the sine of B all over 35. Once again, I'm going to cross multiply. I'm going to say 21 times the sine of B equals 35 times the sine of 81. I'm going to divide both sides by 21 to get the sine of B alone. 21s will cancel out. And I have here the 35 times the sine of 81 divided by 21. So I know that the sine of B will equal 1.64. And if I go second sine of the answer, I'm going to get an error. So what this tells you is that you will have no triangle at all, that this simply doesn't work, that there is no way that you can make a triangle with this kind of a configuration. So as soon as you get an error, then you know that it's not going to work. So your answer here is no solution. This is just simply a triangle that won't work. And what that really means is that you can't actually make a triangle out of those sides. It's sort of like you would end up being like this, where the lengths wouldn't be long enough to actually attach no matter what angle you used. So it would not be able to make a triangle at all. So when you're using the law of sines and you have the side angle configuration, you could have two possible triangles, and you have no idea whether you have one triangle, two triangles, or no triangle at all. Now, please note, it is only the side angle configuration that you have to worry about. If you are using the law of sines and you have, let's see, if you have one of the other configurations where you might have angles, angle, angle, side, then you would be able to do it, or any of the other configurations that work with the law of sines. But if you have side, side, angle, you must check for the ambiguous case. So let's just take a look at an example and see how this would work. So you're given this example, side A is 7, B is 15, angle A is 26. So the first thing you want to do is draw it out. Again, it doesn't matter how you label it. I said ABC, A is 26. The side opposite A is 7, B is 15. The next thing you have to decide is whether you have the side-side angle or angle side-side configuration. If you don't have this configuration, then you don't have to worry about this at all. You'll just go and do your law of sines normally. But if I take a look at this, I have angle, side, side. So this is one of those configurations. So I'm going to solve it normally using my law of sines. I'm going to set it up. I'm going to cross multiply. I'm going to divide by 7. I'm going to figure out what the measurement of the angle is, and I find out that the measurement of the angle is 70 degrees. Whoops, that should have been gone in there. So again, this is kind of what the triangle would look like. I don't know whether I have this triangle right here or if I have this big triangle. If I have the big triangle, then this angle right here would be 70 degrees. So if I fill in my chart and ignore this 110, it's not supposed to be there yet. So measurement A is given 26 degrees, no problem. If I have this angle here, it's 70 degrees. But remember, this is an isosceles triangle, so this is 70 degrees, which means the one next to it here would have to be 110 degrees. So I don't know whether it's the angle I'm talking about is 70 degrees or if it's 110. So if I add these up and subtract them from 180, this here would be 84 degrees, and this one here would be 44 degrees. So either way, I actually get triangles. So my answer would be that the measurement of angle B is 70 degrees, or the measurement of angle B is 110 degrees. So I know that's a lot, but as you work through the homework, if you have any questions, let me know.